Solving exponential equations using log by Alex and Anna. There's 3 different ways to solve solving exponential equations using log. The first method is graphing it. So we can put that in the calculator. The first screen you do y equals 6 to the x, and then y equals 6 to the 10, because our equation is 6x equals 10. When you do that, it will look like this. And when you do that, you need to make sure your window is a little bit above the second number. So I did 15. And then you would press graph. And make sure you can see the line on the top and your graph coming up and where they intersect. And you do second, trace, intersect, and x equals x equals around 1.28. Okay, so that's the first method. The second method, we would do, again, take our equation, 6x equals 10, and you would take the log of both sides, and property of exponents says that you can bring down the x, and it would be x log base 6 equals log 10, and you can divide, so you would divide by log base 6, and that should give you around the same number as 1.28, so let's try that in our calculator. Log 10 divided by log 6. So yes, you get around x equals 1.28. There is another method. The third method, go over here. Again, we have our equation. This time we're going to be using different formula. So we're going to do b to the x equals y, and then we're going to be rewriting it like this. Log base b y equals x. So if we look at our equation, so we have 6 right here, and b is b, so it would be log base 6 to x is over there, so x, and then 10 would be right here. And then change of base formula says that you can do log of 10 over log of 6, which is almost the same as the other method, and you would get x. And again, x equals around 1.28.
Now we're using a different equation, 10x equals 12. So we're going to do the first one, like we did, the graphing. So we put the points in, 10 to the x, and 12. Now we'll just graph it, and remember to put your window a little bit bigger than the last time. And then we find the intersect. So second, trace, 5, enter. So we find that the x equals 1.08. Next, we're going to go on to that other equation. So, bx equals y. We're going to change this over to log b y equals x. And now we're just going to plug in the points. So log 10 So this is the change of base formula, and now what we'll do is have a log 12 over log 10, now equal x. And when we put it in the calculator, we get approximately 1.08, like we had in the graphing. So then we're going to do the third step, or the third method. So I'm just going to rewrite 10x equals 12. And now we're going to take the log of each side. So log 10 to the square root of x equals log 12. Now, because of the property of exponents, we can bring the x down over here. So x log 10 equals log 12. And now we're going to divide log 10 over to the other side. So then that crosses out, cancels out. And we're left with log 12 equals log 10. And, like showing in the other ones, x approximately